Hello everyone. This is part 2 for homework number 6. In the first part we basically reviewed solving linear equations and we saw all the different situations and their general procedure of removing parentheses by the distributive property first, combining like terms, and then we got to a situation where, remember, this is our 3-step process. And so example number 7 was a good example of solving linear equations. Now we get to some special situations. First off, if we have fractions involved, we have two choices. We could either work with the fractions or we could clear the fractions by multiplying by the LCD, which is the least common denominator. So in the first method, working with the fractions, I'll recopy the given equation. We could use the same procedures as normal. The variable's only on one side, so we'll get the constants on the other side. And this would require us to transpose the negative 2/3 by adding the opposite, or adding 2/3 to both sides of the equation. And then the 2/3 go away. We could bring down the 5/2 x, tuck it right in next to the equals. And now this one works out rather neatly because we already have a common denominator of 3. So we can combine the numerators to get the 6/3, or if you prefer, you could say 2. Now, at that point, we could use one of two methods. Recall either the reciprocal method or the cross multiplication method. I'm going to choose to use the cross multiplication method, express the left-hand side as 5x over 2 instead of 5 over 2 times x, and express the right side as a fraction by putting the 2 over the 1, and then we can cross multiply. We get 5x equals 4, and then finally divide. And if we're dividing by 4, actually let me bring it up here. We've got 5x divided by, we're not dividing by 4, we're dividing by 5, excuse me. We get x equals 4/5. Okay, so that's working with the fractions. If we want to clear the fractions, let me recopy the original equation again. What we do is we determine the least common denominator, which in this case is 6, the product of 2 and 3. And then we basically multiply both sides of the equation by 6. And you could show that literally here by putting parentheses around both sides and indicate that you're going to multiply by 6. Now when we distribute that 6, let me show it this way. Basically, one of the things you could do, I'm showing it literally by multiplying both sides by 6, but what some people will do is they'll multiply the 6 by every term, because that's really what happens when you distribute. So I'm going to recopy the original equation. I'm just going to show a 6 multiplied by everything. And then what happens is 2 goes into 6, 3 times 5 is 15, so we get 15x. Here 3 goes into 2, 2 times 2 is 4, so minus 4 equals, and here 6 goes into 6 once, and we just, oh, I'm sorry, that's not minus 4, that's minus 2. No, it's minus 4. And here I recopied that wrong, that's the problem. That was a 3 in the denominator. And 3 goes into 6, 2 times 4 is 8. Okay, and now we can solve for the variable. It's on this left side, so we'll get rid of the negative 4 by adding 4. Bring down the 15x, that equals 12. And then our division, divide by 15. So we get x equals 12 over 15, but that can be reduced by a factor of 3 to give us 4/5. Okay, so it's your choice as to what method you want to use, and that's how we deal with fractions. Or we could see a situation where it's set up so that it's advantageous to just simply cross multiply. So we could take, in this example, the 4 crossed over. Now here I'm just going to multiply it by the 3, that's the coefficient, to get 12, and leave the 3x minus 2 in parentheses. And then equals, bring over this 3 times the 2 is 6, and leave the 2x plus 1 in parentheses. So either that, cross multiply, or you could multiply both sides by the least common denominator, which is 12, and you'd get to the same point. But then we need the distributive property. So 36x minus 24 equals, distribute the 6 times 2x is 12x, and 6 times 1 plus 6. Variables on both sides. This is our situation for the 3-step process. I'm going to bring the variable to the left by subtracting 12x from both sides. And we get 24x, bring down the negative 24, equals, the x's are gone on the right, and that's bring down the 6. If I brought the variable to the left, I want to bring the constants, or the numbers, to the right. Transposing a negative 24, we add the opposite, or add 24. And bring those 24's are gone, bring down the 24x, 6 plus 24 is 30. And now finally the division, and dividing by 24, we get x is 30 over 24, but that could be reduced, and I think by a factor of 6 is the greatest common factor. Oops, I'm sorry, wasn't showing you that, I was just writing it. So after the division, we get 30 over 24, and now the greatest common factor is 6. So if we divide by that, 30 divided by 6 is 5, and 24 divided by 6 is 4. Okay, so there's some examples of how we deal with fractions. And now the final page for homework number 6 are some very special cases. These are situations where, up until this point, we have had situations where we were able to solve for x, and we came up with x equals some number. And it could have been a whole number, an integer, or, as we've seen, fractions. But now we see a situation where, as we go through the process of solving for the variable vanishes. And if the variable does vanish, basically disappears, not by magical things, it's just mechanically, it just goes away, you're going to end up with a statement between two numbers. And if you get a true statement, the answer would be all real numbers. And if your statement is false, then we would say no solution. So, in this example, now the first two examples are simple ones where you might be able to tell. And the reason why I'm saying you might be able to tell is because the variable is on both sides, but it's the same. And so if you attempt to bring the variable to either side, it doesn't matter which side you would choose, you would have to subtract 3x. But if you subtract 3x from both sides, notice how the variable vanishes from both sides. And you just end up with a resulting statement, in this case, that 4 is equal to 5. And obviously, 4 is not equal to 5. So this is a false statement. So then our solution is that there is no solution. There's no value of x that's going to satisfy this equation. So no matter what you pick for x, nothing works. Now, in number 11, you could tell just by inspection that this is what we might refer to as an identity equation, because the right-hand side is the identical same thing as the left-hand side. So therefore, the solution, since they're exactly the same, put in any number for x and anything is going to work. So therefore, the solution, we would say, is all real numbers. But mechanically, if you go through the process and you try to eliminate the variable again, so let me recopy, and let's say you subtract 5x from both sides, again, the variable vanishes from both sides. But here we get the statement that 7 equals 7. And 7 equals 7 is a true statement. So then the solution we report is all real numbers. Now, those were kind of easy because we only needed one move to realize that it was this special situation. But in numbers 12 and 13, you can't tell just by looking at them that it is this special situation. So you have to go through the process. Distributive property first. 5 times 2 is 10. 5 times negative x minus 5x. Remember, there's a 1 in there if you want to slide the 1 in front of the x. The closure of the parentheses stops the distribution, so we'll recopy the plus 8x, and that equals, on the right, we distribute the 3. And again, there's a little 1 that's understood in front of the x. And 3 times x gives 3x. And 3 times negative 6, negative 18. Okay, before we start to transpose, we're going to combine like terms on either side of the equals. And on the left, we see a negative 5x and an 8x can be combined to give us 3x. We'll recopy this 10, and we have to put a plus in between to separate the terms. And that equals, on the right side, we'll just recopy 3x minus 18. And now we can see that when we try to solve for the variable, by subtracting 3x from both sides of the equation, it is one of the special cases where the variable vanishes. And we get the statement that 10 is equal to negative 18, but obviously that's not true. 10 is not equal to negative 18, so therefore this is a false statement. That means the solution is that there is no solution. So you can't really tell just by looking at the equation if these special cases are going to be the situation. You just have to go through the process and then realize that if the variable vanishes from both sides, it is this special case. So we'll finish off with this last example. First off, standard procedure, 5 gets distributed, times x is 5x times negative 2 minus 10. Closure of the parentheses stops the distribution. Recopy the +1. Recopy the equals. Distribute 3 times x gives 3x times -3, -9. Closure of the parentheses stops at the distribution of the 3. So just recopy the +2x. Notice we have more than two things on either side, so that means we can combine like terms. On the left, the 5x is the only variable term, so we recopy, but then combining the -10 and the +1, we get -9. Recopy the equals. On the right side, notice like terms are the x's. 3x plus 2x is 5x, and recopy the -9. And now you might see it right away. That's an identity equation. So you could say all real numbers immediately. But if you want, show the process by subtracting the 5x from both sides. And now we see the variable vanishes. And we have that -9 equals -9, which is a true statement. So then we report that our solution is all real numbers. Okay, so that's the end of homework number 6 and solving equations. So we'll see you when you're ready for homework number 7.